Okay, previously we have solved this problem. Whether my screen is visible to you people? We have solved this problem
Yes, sir.
by using two methods. One is by graphical method, another is by big M method. Now, as I told you, if you want to solve this kind of problem, we are greater than or equal to sign is included, and because of that, artificial variables will be present in the problem. Then there are two ways to solve it. One is big M method, and another is what is the second method? Can you look?
Two-phase method.
Two-phase method, yes, correct. So we will solve this problem by two-phase method now, so that you will understand the two-phase method as well. So you take down this problem again. Minimize z is equal to 40x1 plus 24x2, subject to linear constraints of 20x1 plus 50x2 greater than or equal to 4800, 80x1 plus 50x2 greater than or equal to 7200, x1 and x2 greater than or equal to 0. So we have discussed about, yeah.
Google Meetचं हे दिसतंय आम्हाला प्रॉब्लेम नाही दिसत.
प्रॉब्लेम दिसत नाही.
नाही सर, गुगल मीटच हे दिसतंय.
Presenting entire screen I am presenting. Now one note is not visible.
नाही सर, नाही दिसत.
ते तुम्हाला पिन करायला लागेल. माझं प्रेझेंटेशन जिथं चालू आहे तिथं पिन करून बघा. बाकी कोणाला एकाला तरी दिसतंय का वन नोट?
नाही सर.
Yes or no?
No sir.
No sir. No. Why it is happening so? मी जिथनं प्रेझेंट
एकच विंडो सिलेक्ट झाली असेल, प्रेझेंट एंटायर स्क्रीन झालं नाहीये.
प्रेझेंट एंटायर स्क्रीन नाही झालं. स्टॉप प्रेझेंटिंग करतो. I think now it is visible to you people.
Yes, sir.
Yes, no?
Yes, sir.
Okay, so take down this problem first. You write down it again on a separate page, and then we will solve it by using two-phase method. Okay, have you taken this problem?
No, sir.
Not yet.
No, sir. 2 minutes.
Okay, now we will start solving this. Okay, so in big M method, we assign a very big amount that is called as M to artificial variable in objective function. Okay, now if objective function is minimization, then big M is having plus sign or minus sign? For minimization,
plus sign.
Plus sign. And for maximization objective function, it will be minus sign. So we will rewrite this problem. Now for two-phase method, you have to write a standard form in such a manner that that standard form will be useful for the first phase. Okay, two-phase method. And the problem is required to be solved in two phases. The purpose of first phase is to remove the artificial variables from the base, and then the second phase is to solve the problem for optimal solution. So it is called as two-phase method. So the problem is minimize Minimize z is equal to, tell me the values.
40x1 plus 24x2.
40x1 plus 24x2. Okay. Then you have to convert it into standard form. So you are supposed to write standard form. So subject to, what are the constraints? Tell me. First constraint.
20x1 plus 50x2
20x1 plus 50x2
greater than equal to 4800.
minus s1 plus a1 is equal to 4800. We are writing standard form now. Okay. Then what should be the next constraint? What is the next?
80x1
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 plus 50x2
plus 50x2
minus s2
plus 8
plus
is equal to
is equal to
7200. Is it okay? Okay.
yes,
Now, while writing the standard form in two-phase method, you have to consider zero coefficient for S1, zero for S2 in the previous manner. मी लेक्चर मध्ये आहे 4:30 वाजता. Okay, and then for minimization problem, you take only plus 1 as the coefficient of A1 and plus 1 as a coefficient of A2. In big M method, we have taken M as the coefficient and assigning plus sign to that in minimization problem. But in two-phase method, you have to consider 1 as the coefficient in the objective function. Okay, and for minimization it is plus sign, for maximization it will come with minus sign. And now in the similar manner you can write x1, x2, s1, s2, a1, a2 greater than or equal to 0. Is it okay? Now can you write the initial basic solution for this particular problem, for this particular standard form? Can you write it? Yes or no?
Yes, sir.
Okay, try to write it and complete. Initial basic table, basic solution table. In the similar manner as usual, what we were in the we are writing previously. There is one small correction while telling you these things. While writing the standard form, you have to consider zero, zero as the coefficient of decision variables as well. Decision variable coefficient will also be 0. Okay, so just make a correction here. When you are using two-phase method, lecture मध्ये when we are using two-phase method, we are supposed to write these coefficients as 0. Okay, so we are not considering the original problem. We are changing the objective function. We are considering the decision variable and surplus slack variable coefficients as 0 and artificial variable coefficient as 1 in the objective function, and we are writing the constraints in the similar manner as we have written them previously. Now write the initial feasible solution. Okay, so it can be written like this. So x1, x2, s1, s2, a1, a2, bi. Here it will be a1 and a2. The Cj values will be a converted problem is having Cj value. Here it is 0, here it is 0, 0, 0, 1, 1, 0. And here it is 1 and 1. Now in the similar manner, you can write Zj and Cj minus Zj. Here. So 20, 50, minus 1, 0, 1, 0, 4800. 80, 50, 0, minus 1, 0, 1, 720. इथपर्यंत सगळ्यांच्या लक्षात आलं? In two-phase method, you have to convert the objective function in such a manner that the coefficients of decision variables as well as surplus slack variables should be 0, 0, 0, and artificial variable will have the coefficient 1. If it is minimization problem, it will be plus 1 for artificial variable, and for maximization problem, it will be minus 1. Okay? Is it okay? And the purpose of this particular converted standard form is to complete the first page, in which we are interested in removing the artificial variable from the base. If artificial variable is present in the base, then that is not the feasible solution. The solution is called as infeasible. I'll discuss that matter later on also. But before that, you try to understand this two-phase method. Okay, this much is understood.
Yes, sir.
Okay. In the similar manner or as usual manner, you can find out Zj and Cj minus Zj. So what will be Zj here? Zj will be 100. Okay, and Cj minus Zj will be 0 minus 100. So minus 100. Similarly, here Zj will be 100 and 0 minus 100 will be minus 100. Then here it will be minus 1 into 1 plus 0. So minus 1, 0 minus 1 plus 1. Here it will be again plus 1. Here it will be minus 1. This will be, no, here it will be 0. 1 minus it will be 0 here. Here also 0. And you need not have to calculate Cj minus Zj below Bi. Okay, this much is okay?
Yes, sir.
ओके. ठीक आहे. काय केलं लक्षात आलं? पहिल्या फेज साठी म्हणून ऑब्जेक्टिव्ह फंक्शनची ऍडजस्टमेंट केली आणि ऑब्जेक्टिव्ह फंक्शन थोडं वेगळ्या पद्धतीने लिहिलं by considering 0 as coefficients of decision variables as well. Instead of taking big M, we have taken 1 as the coefficient of A1. Okay. And then we have written this particular table, which is called as initial basic solution. Now, whether this solution is optimal?
No.
No. Why it is not optimal?
Negative value present.
Negative value of Cj minus Zj is present. Now you have to choose largest negative Cj minus Zj column. But here there are two values which are having same value. Okay. Same largest negative value. Am I right?
Yes.
Okay. If this is the case, if there is a tie between Cj minus Zj, selection of Cj minus Zj value, then you can choose it arbitrarily. Okay, arbitrarily anyone. But you try to choose, if at all there is a tie between two decision variables, then choose any one of these two. If there is a tie between decision and slack variable, then choose decision variable. If there is a tie between decision and surplus variable, choose decision variable. If there is a tie between two slack or two surplus variables, then choose any one arbitrarily. If there is a tie between slack and artificial variable, then choose slack variable. If there is a tie between decision and artificial variable, then choose decision variable. But generally, artificial variable is not coming into the base again, so there will not be tie with respect to artificial. But in rare cases, the possibility is there. So you, for the time being, you forget about artificial variable and focus on decision and slack or surplus variable. If there is a tie between two decision variables, what should be the criteria?
Choose anyone.
Can be chosen on
Anyone, arbitrarily anyone. Okay. If there is a tie between two slack or surplus variables,
Choose anyone.
anyone, arbitrarily you have to choose. If there is a tie between decision and slack or surplus variable,
Decision variable.
decision variable. Why? Because we want to take the decision variable into the base. So if at all value to the decision variable is assigned, then we can, it will be better for getting the solution value. So we are making. Otherwise, you can choose arbitrarily anyone. That doesn't matter at all. Now here there is a tie between x1 and x2. You can choose anyone. As x1 is first, I'm choosing x1. Somebody can choose x2 and start. Somebody can start with x1. No problem. Now improve the solution in the usual manner. Can you do that? And write down the next table. Now, in order to improve the solution, you have to calculate BI upon AIJ. BI upon AIJ. As the key column is known, you can find out BI upon AIJ. Now tell me what is the value BI upon AIJ here? First one.
240.
240. Second,
90.
90. Now the same criteria, choose minimum non-negative value of BI upon AIJ for taking the outgoing variable, for deciding the outgoing variable. So at the place of A2, X1 will be there. Somebody can start with X2. X2 च्या केसमध्ये BI upon AIJ चेंज होईल. कुठला येतोय बघा, A1 रिप्लेस होतो का A2. You can check it and you can solve it. Now write the second table. Second table तुम्ही सोडवा.
सर जर आर्टिफिशियल आणि स्लॅक और सरप्लस असेल तर कुठला चूज करायचा? आर्टिफिशियल आणि स्लॅक और सरप्लस असेल तिथं बेसमध्ये
तर स्लॅक किंवा सरप्लस घ्यायचा. Actually, artificial variable should not be in the base. It will not give you the physical solution. त्यामुळे तसा काही येणार नाही, कारण आर्टिफिशियल ऑलरेडी बेसमध्ये असतोच. बेसमध्ये असलेलाच परत बेसमध्ये येण्यात काही पॉईंट नसतो ना. त्यामुळे तसा टायची संभावना खूप कमी असते, शक्यता खूप कमी असते, खूप रेअर केसमध्ये. बट यू नीड नॉट हॅव टू वरी अबाउट इट ॲट दिस पॉइंट ऑफ टाइम. Okay, we have started two-phase method, and this much we have completed. Then this thing also completed. Now write down the second table. Some people can solve it by taking x2 into consideration at the initial stage. Ultimately, they will reach to the same solution. Okay, completed the second table. Have you completed second table?
Sir, एक minute.
सर सेकंड टेबल मध्ये A2 लिहिलं नसलं तरी चालते ना A2 कॉलम
सेकंडला काय म्हणाला?
A2 चा कॉलम
आवाज नाही येत आहे.
सेकंड टेबल मध्ये A2 चा कॉलम लिहिला नसला तरी चालेल ना?
चालेल, yes. Once the artificial variable gets removed from the base, you need not have to rewrite it in the column. In the next table column. Okay, now just check that whether you got second table in this manner or not. ज्यांनी x2 घेतला असेल थोडा त्यांचा बदलला असेल पण don't worry, ultimately you will come to the same solution. असं आलंय का सगळ्यांचं सेकंड टेबल?
हो सर आलाय.
Okay, now it is not again optimal solution, so there is a scope for improvement. Then you can consider Cj maximum negative value of Cj minus Zj for selecting the key column. So that will be the x2 column. Am I right? So after choosing the x2 column, you have to write bi upon aij values, and it will be 80 and 144. Now choose minimum non-negative bi upon aij for deciding the outgoing element. So that is A1 now, and A1 will go, and at the place of A1, X2 will come in the next table. Now in the usual manner, you have to complete the next table by making the usual row transformations or calculations. Okay, now you just check it whether you got this solution.
Yes sir.
Yes sir.
Forget about A1, A2, you need not have to write it. I just written it for understanding only. So if at all this is the same solution you got, then now you see that there is no artificial variable in the base. Am I right? So here the first page is over. Here first page is over. Now for first page, we have made some adjustments in the objective function, and we have solved it only for removing the artificial variable from the base. Now the same table, whatever is there, you have to rewrite. Only thing is that you have to take the original contributions of x1, x2 into the problem. The same values at all places you have to write. Only there will be change in the value of Cj coefficients of x1 and x2, row wise as well as column wise. So can you rewrite this? Tell me, what should I write? Here it will be x1, x2, s1, s2 and bi. Okay, so what is there? X2 and X1. So here it will be X2, then X1. Now what are the original coefficients? It is 40,
24.
40 and 24. This is having 0, 0. Initially you can consider 0 here now. Then it will be for 24 and this will be 40. Then you can write Cj minus Zj. By making the calculations. Okay, this will only change. Or other things will remain as it is as that of the previous problem, previous table rather, which we got after removing the artificial variables from the base. So this will be, yes, of course, 0, 1, 1, 0. And here it will be 0, 0. Then next minus 2 by 75. Then S2 will be 1 by 150 below S2. The in front of BI it will be 80. Then 1 by 60 minus 1 by 60 and then 40. Now you have to calculate these values Cj minus Zj below S1 and S2. Even X1 and X2 also you have to calculate, but it will come 0 if you calculate it. Now for calculating this you have to first find out Zj. First find out Zj and then find out Cj minus Zj. They are directly written Cj minus Zj. You have to find out Zj first so that Cj minus Zj can be easily written. Okay, or should I rub it and rewrite? So you have to find out Zj first and then Cj minus Zj. So this will be 0, this will be 0. You first find out Zj and then find out this. This is 40, so it is coming as 0. This will be 24, so it is coming as 0. So can you tell me Cj minus Zj directly?
Minus 2 by 75.
Hmm.
38 by 75.
Where? Below S2 or S1?
Below S1 minus 2 by 75.
My S1 minus 2 by 75
Below S2 minus, 38 by 75.
plus 38 by
75.
Okay. And what will be this value?
2 by 75 minus 38 by 75.
Minus 3520. Is it minus 3520?
Yes, sir.
So you find out ZZ there and subtract it from 0, you will get minus 3520. Am I right? Just for verification, we can use that value. Otherwise, you need not have to calculate. Directly when you put the optimum values into the objective function, you will get the Z-min or Z-max, whatever is asked. Okay, now tell me whether this solution is optimal for minimization problem.
No, sir.
No, so choose maximum negative Cj minus Zj value as the key column. Okay. So here there is only one, so this will be key column. Now find out BI upon A as usual. So here BI upon A will be minus 3000. If at all it is negative value is there, you can put dash or you can write the negative value. No problem. Then choose minimum non-negative value for deciding the outgoing variable. So at the place of x1, s1 will be there, and you have to write the improved solution by making the calculations in the usual manner. So can you do that? Okay, complete it now. So that's what we have done here. It is 40. Oh, 4:30. 15-20 मिनिटं. अजून 20 मिनिटांनी या. Okay, so this is the table which we have written now. Now you have to improve it. Okay, all of you are doing the calculations, no? कंटाळा अजिबात करू नका, कारण मला इथून काही दिसत नाही तुम्ही काय करताय काय नाही. नुसतं निवांत बसला आणि ऐकत बसला तर त्याचा काही उपयोग नाही. Until and unless you solve the problems, it will not be possible for you people to get the answers. Okay, if I am solving it, I am teaching you all these things, I am showing the tables, I am making the calculations, it will not be helpful for you people. You have to make the calculations. If at all you are having any doubt, you just ask me. So don't be lazy to make the calculations. Make it and write it. If at all any wrong answer is there, you again scratch the table, rewrite it. But then that is required. Okay, once you can do this, then it will be easy for you to handle 2 units, module 1 as well as module 2, because everywhere these kind of calculations are required. Okay, have you completed? The next table?
Yes, sir.
Okay, now you just check that whether you got the same table. This one only. Am I right?
Yes, sir. Yes, sir.
This is the same table. Okay, now the value is x1 is equal to 0, x2 is equal to 144, s1 is equal to 2400, and our zmax is 3456. Now you can cross check these values with your previous two solutions, one by graphical method and one by big M method. Is it okay? Have you got this much portion, whatever I have discussed with you people?
Sir,
Yes, sir.
Yes.
सर ते जेवढे मेथड आपण बघितले त्याच्यामध्ये मॅक्सिमायझेशनची जी ऑप्टिमॅलिटी टेस्ट होती ती पॉझिटिव्ह वाला मॅक्सिमम आणि मिनिमायझेशन मध्ये मॅक्सिमम निगेटिव्ह आला ना.
माझं काय तर चुकलं का लिहायला, झेडमिन लिहायला पाहिजे, झेड मॅक्स नाही.
हा झेड मी
इट इज झेडमिन. दिस इज रॉंग. This must be Z mean. This is not Z max, this is Z mean. Is it okay?
Yes, sir.
आता काय डाऊट होता तुझा मगाशी मला कळलं नाही नीट.
सर आपण जेवढे मेथड बघितलं त्याच्यामध्ये मॅक्सिमायझेशनच्या प्रॉब्लेम मध्ये ऑप्टिमॅलिटी चेक जो असतो तो पॉझिटिव्ह मॅक्सिमम आणि मिनिमायझेशनच्या प्रॉब्लेम मध्ये ऑप्टिमॅलिटी चेक मॅक्सिमम निगेटिव्ह येतं ना.
होय, मी जे सांगितलंय ते आतापर्यंत
कोणती
जे सांगत आलोय ते कसं आहे.
कोणती पण method
मॅक्सिमायझेशन तुम्ही फक्त मॅक्सिमायझेशन प्रॉब्लेमच लक्षात ठेवू शकता आणि एव्हरी प्रॉब्लेम कॅन इव्हन मिनिमायझेशन प्रॉब्लेम इज देअर वी कॅन कन्वर्ट इट इनटू मॅक्सिमायझेशन and solve it by maximization methodology. But then for simplex convergent and then all these things may become somewhat complicated. So I have taught you both the things. And for maximization and minimization, separate methodology I have taught you, and you have to apply it as it is, whatever we have discussed or whatever I have taught you, and you try to finish it in this manner. Otherwise, every minimization problem can be converted into maximization and we can solve it. That is another way of solving. In some books you will find that also. But for this particular simplex method, I am teaching you two different ways. For Zmax one way, Zmin another way. Only difference is that applying optimality check, one thing. Applying optimality check. And if at all big M method or two-phase method is there, sign of the artificial variable in the objective function. That you need to focus. आता विचार तुझा काय डाऊट होता.
हा सर, मग मिनिमायझेशनच्या प्रॉब्लेम मध्ये आपण म्हणजे ज्या मेथड्स बघितल्या सिम्प्लेक्सच्या त्यामध्ये मॅक्सिमम निगेटिव्ह बघायचं ना, सीजे मायनस झेडचे, आणि मॅक्सिममच्या प्रॉब्लेम मध्ये मॅक्सिमम पॉझिटिव्ह.
मॅक्सिमम पॉझिटिव्ह, करेक्ट.
तेवढंच कन्फ्युजन होतं सर.
ठीक आहे, ते कुठं तर लिहून ठेवा. जेव्हा जेव्हा मी काही वाक्य सांगतोय ना अशी, तर ते तुम्ही लिहून ठेवायची मराठी, हिंदी, इंग्लिश मध्ये, तुम्हाला ज्या बाजूला किंवा वरती असं डोक्यावर कुठेतरी. लक्षात आलं का? म्हणजे ते प्रॉब्लेम सोडवताना तुमच्या लक्षात येईल. आता इथं मी सुद्धा इथे लिहिलंय बघा वरती, इन द बेस ओनली आर्टिफिशियल and or slack variables. Then here also somewhere I try to write something at the top or top of the page. That is nothing but we can remember those notes for solving the problem. Okay. Now, if at all you have completed this, you can verify the solution with previous. ज्याने x2 आधी घेऊन सोडवला होता त्यांचं सुद्धा हेच उत्तर आलं असेल. बरोबर आहे? x2 आधी घेऊन सोडवला होता त्यांचा इथंच आर्टिफिशियल व्हेरिएबल जिथं चेंज होतं तिथंच उत्तर सेम आलेलं असणार आहे. ओके, सो दॅट डझंट मॅटर. यू जस्ट or you can try it by yourself later on and do it. Okay, so here I have completed most of the syllabus. One kind of variable, that is unrestricted variable, problem is required to be conducted. But before that, I want to discuss with you people that whenever artificial variable is present in the base, I am calling it as initial basic solution, not initial basic feasible solution. Why? I will tell you. Now you just take this problem. Which one? This into consideration. Okay, let us take this problem into consideration. So here, what are the basic variables? You just focus on initial table and tell me what are the basic variables. Basic variables are those variables which are present in the base, means arranged row wise.
A1 and A2.
A2. Okay. Now, what are the solution values of this particular table? Can you tell me? Solution values of this particular table, or what is the initial solution with which we are starting?
A1 is equal to 4800. A2 is equal to 7200.
Okay. Now, if you take A1 is equal to 4800 and A2 is equal to 7200, okay, That means we are starting with artificial variable present in the base. Artificial variable present in the base. And if you put those values in objective function, plus m into a1, that is 4800, and plus m into a2, that is 7200. Whether you will get minimum value, you will get z value, which is very, very big. That means at the infinite level. Okay, and artificial variables are present in the base. So this is not the feasible solution. This is not the feasible solution. We have to subtract something from left hand side so that right hand side can be achieved because it is greater than or equal to sine. But if we are adding something to this and we are achieving left hand side, right hand side. So this is not feasible solution. So I am calling it as initial basic solution, not initial basic feasible solution. Okay. So whenever artificial variable is present in the base, this is not the feasible solution. So our attempt is to remove the artificial variable from the base. But we have to focus on whether the solution is optimal or not. Means optimality check is required to be applied at every stage. If optimality check test gets satisfied and still, that means the solution is optimum and still the artificial variable is present in the base, the meaning is that this problem is having infeasible solution. Feasible solution is not possible for this problem. Now you have recently solved some graphical special cases of graphical method. You might have found one problem where infeasible solution is there. Am I right? Am I right?
Yes.
Am I right? Yes. Okay.
Yes,
Now
sir.
if you solve that problem by using big M method or two-phase method, you will find that you will get the optimality check satisfied, but artificial variable is present in the base. Now that situation is infeasible solution. You try it later on and try to solve it by simplex method. मी तुम्हाला काल ते असाइनमेंट दिलेली आहे. ग्राफिकल सोल्युशनने जेवढे प्रॉब्लेम सोडवलेले आहेत ते परत सिम्प्लेक्सने सोडवा. म्हणजे स्पेशल केसेस मध्ये काय प्रॉब्लेम येतो ते लक्षात येईल. तो आपण नंतर डिस्कस करणार आहोत. ठीक आहे. इथपर्यंत तुमच्या लक्षात आलं का आर्टिफिशियल व्हेरिएबल असेल तर काय प्रॉब्लेम आहे. आता मला सांगा बिग एम मेथड सोपी आहे का टू फेज मेथड सोपी आहे. एकच प्रॉब्लेम आपण दोन्ही मेथडने सोडवला. Which is simple method according to you?
Two-phase method.
टू फेज. आणखी कुणाच काय म्हणणं आहे का वेगळं का सगळ्यांना टू फेजच सोपी वाटते.
टू फेज मेथड
सगळ्यांना
Yes,
okay. Two-phase method seems to be simpler. Why? Because a big M calculation is not required. That M will not taken into effect while doing the calculations, and calculation part will become easy. But in two-phase method, you have to remember that decision variable coefficients initially we are taking 0, and only first phase is solved for removing the artificial variable. You have to rewrite the problem by taking original coefficients of decision variable and then solve it again. So one table will be required additionally. Am I right? Most probably one table will be required. One additional table will be required. So that is there. Now you see which method is easy for you and you can use any one of these two until and unless specifically asked in the exam or in the question. In some problem it is directly asked that solve the following problem by big M method. Then you have to apply big M. You can't go for two phase. Okay, if at all in the exam a question is given and it is written that solve the following problem by using or solve the following LPP by using big M method, then you have to apply big M. If you apply other method, then you will get a big 0 from the evaluator. Am I right? Are you getting? If it is mentioned that solve the following problem by using two-phase method, then apply two-phase method for solving it. But if at all nothing is mentioned, solve the following LPP by simplex method or solve by the following LPP. If it is only mentioned, then you can apply any one of these which you are comfortable with. But my suggestion is that apply big M method because you are getting the solution in one stroke. You are starting with the same problem and going towards optimality. You are not changing the problem at all. So there may be chance that you may make mistake in converting the problem in two-phase method. But if you are comfortable with, I don't have any problem. I always prefer big M method instead of two-phase. Okay? Is it okay? इथपर्यंत लक्षात आलं का?
Okay, sir.
Okay. Now take down one more problem in which we are going to consider one variable which is called as unrestricted variable. Okay. Okay, I'll just read that problem. Where is it? Maximize z is equal to maximize z is equal to 3x1 plus 2x2, 3x1 plus 2x2 plus x3. Okay, subject to linear constraints of 2x1 plus 5x2, 2x1 plus 5x2 plus x3 is equal to 12. Second is 3x1 plus 4x2 is equal to 11. And what is written here is x2 and x3 greater than or equal to 0 and x1 is unrestricted in sign. Unrestricted. Unrestricted means unrestricted in sign. Is it okay? Don't get the problem?
Sure, sir.
Okay. Now, x1 is unrestricted in sign means what? X1 may be negative. X1 may take negative value at any point of time, or optimal value of x1 may be negative also. Okay. What is our assumption? The decision variables are always taking positive value. But here what is given, or what condition is given? One variable is given as unrestricted in sign. That means it may assume positive value or negative value. Okay. अशी केस असू शकते काही काही गोष्टींमध्ये. For example, I am having a company. Initially, I am getting some profit. Okay, and again I am solving another problem where my profit margin got reduced. Okay, so difference between these two is negative. Next minus previous is negative. But actually I am getting some profit. Are you getting me? But the value is reduced. And I am considering difference between these two as my decision variable. Then it may assume negative value. Are you getting me? Are you getting me?
तर आणखी इथं
Suppose, okay, I'm selling, say, cars. And this year, for a particular model, a particular profit I'm earning, say 5 lakh rupees. Okay. Next year, the same car I'm selling, but my profit margin is 3 lakh rupees. So, what is the difference between the profits?
2 lakh.
3 lakh minus 5 lakh. 5 lakh previously होतं, आता मला 3 lakh मिळते. म्हणजे मला आता मागच्या तुलनेमध्ये किती लॉस आहे किंवा किती प्रॉफिट मध्ये डिफरन्स आहे? -2 lakh. Am I right?
Yes, sir.
-2 lakh. But still I am getting some profit. But I am considering difference between these two as my decision variable. That is, reduction in profit is my decision variable, or difference in my profit. which is nothing but the loss this time to me. Am I right? So as it is loss,
Yes, sir.
it is having negative sign. Though I am getting some profit and I am selling the products only, the positive products, no doubt about it, positive number of products, not the negative number of products, positive number of products, but still my decision variable value is negative. So this kind of cases may happen in practice. Okay. So sometimes in rare cases, but the possibility is there. The one or more of the decision variables may be unrestricted. Now here x2 and x3 are greater than or equal to 0, but x1 is unrestricted inside. So x1 can take positive, 0 or negative value, means it is unrestricted. Are you getting the meaning? Are you getting the meaning of this? Yes or no? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Now, how to solve this problem? Because while solving the problem, we have to consider all the variables greater than or equal to 0. So we have to convert this problem in such a manner that we can stick to our non-negativity condition. Okay. How to do that? That we will discuss for the next lecture, and then we will solve that problem in a different way. Different way means in a similar way, but this particular problem is having some tricky condition as well. Okay, that we will discuss for the next lecture. So today we'll stop here only. Is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now I am considering that you have uploaded the videos, not videos,